So good evening, guys, and today we'll be talking about the two problems. So last day I couldn't, yesterday and day before yesterday I couldn't upload the problems because there was some issues with the website. So today we will be discussing the problems that we have uploaded of like yesterday and day before yesterday, and let's get started with those two problems. And those two problems are aligned with the current topic of platinum batch, where we are discussing the problems. I think joint distribution is happening and conditional moments is a very important part of that. So we will check how this like how to solve this kind of problems, and these are not really like hard, but these are really some like some intricate ideas, delicate ideas are needed to understand this. Okay. Okay, so give me a minute. I have, like, I think there's some mic issues, so I will just check whether the streaming is audio is visible, is being properly recorded or not. Just give me a minute. Issues, I will just. Okay, yeah, it's properly being recorded. So let's get started. So let's discuss this problem. This problem on the 22nd September's problem, and after that we'll be discussing certain doubts which are not cleared till now. So now understand that in this problem it's given that x1, x2, x3 are three IID standard normal random variables, and it's asked to find expectation of 2x1 plus 3x2 given x1 plus 3x2 minus x3 is equal to 4. So any ideas, guys, on how to approach this kind of problem? Any ideas do you have on your mind how to approach this kind of problem? All us.
Sir,
Yeah.
you can use the additive principles, sir.
Yeah, so tell me, what is that additive principle?
Sir, E of x1 plus x2 is equal to E of x1 plus E of x2.
Okay, so okay, just let me just write it down. So is it Nikhil speaking now? Or like I actually couldn't recognize the voice.
No, sir.
It's Madhav.
Yes, sir.
So expectation of twice x1 plus thrice x2 given x1 plus thrice x2 minus x3 is equal to 4. Okay, so Madhav is telling that by the additive property of the expectation, the linear property of the expectation, we can write it as twice expectation of x1 given x1 plus thrice x2 minus x3 is equal to 4 plus thrice this is what you're talking about, right?
Yes, sir.
Okay. Yeah, so then what, Madhav? What ideas do you have after this? So you found out properly that you're using the linearity of expectation over here to find out that since x1, x2, x3 are IID standard normal variables, z say. So can we use addition of two random? Yeah, I mean, that's why I'm asking for ideas, guys. I'm not giving a definite solution. I'm asking for ideas from Ian, guys. So this is what Madhav has told, and then what should we do? So this is, I'm trying to make it a discussion format because since you're learning for the first time how to apply this on problems. Any ideas? So I will show you two different methods. What is not properly visible on Zoom? Yeah, so the school of thought is thoughts are coming forward that let's compute the like the distribution of this. So 2x1 plus thrice x2 follows normal 0 comma 5. That's true. And sorry, I'm so sorry, normal 0 comma 4 plus 9 13 and whatever. So we can compute that. So what's after that? What's after that? What's after that? You're right. Yeah, Anjum, I couldn't understand that what you can't see, whether it's a problem or what you can't see. Can you just be more specific, Anjum? Yeah. So after this, how will you approach this problem? Like, given this problem, what is coming to your mind? So it's given expectation of this. So how what is coming to your mind? So it's coming that we need to find the distribution of 2x1 plus like 3x2 given.
Oh,
Yeah.
so will 2x1 plus 3x2 and x1 plus 3x2 minus x3 be independent?
Okay, so let's address this question. You're asking that whether.
So the first term 2x1 plus 3x2
Okay,
and x1 plus 3x2 minus x3.
are they independent or not? So how will you check independence here? What is the first step to check independence over here?
So whether row is 0 or not?
Yeah, the first step is to check whether there is a correlation or not. I mean, correlation doesn't imply independence, okay? But in normal case, they do, okay? So when you're checking to like correlation of two non-random variables, they are uncorrelated, like they're uncorrelated if and only if they're independent, okay? So that's the result. But here, always checking about independence, you should be checking whether they are uncorrelated or correlated or not. That's very important, the first step. So can you just check whether they're uncorrelated or correlated, guys? Sneha, what do you think? Can you compute it? What is the covariance of this two? What is the covariance of this two?
So when I calculated the covariance, it was coming out to be 11.
Yes, it's coming out to be 11. So let's calculate the covariance and you will find out, Sneha. So can you just tell me how will you calculate this covariance? Bolo? How you
So,
can? Yeah.
so expectation of 2x1
Expectation?
plus
Okay, so there are some covariance rules. Do you know the covariance rules? The results of covariance?
got it.
Huh? Kya, what? I couldn't hear you, Sneha. You told something. Told me something.
So you mean that like the one we had an addition of two random variables, the covariance,
Yeah,
right?
yeah. That's property.
So we can write it like this: covariance of 2x1, comma x1 plus 3x2 minus x3
Okay, and
plus a covariance of 3x2, comma x1 plus 3x2 minus x3. Likewise, we can bifurcate the second term as well.
okay, so do that and tell me what will come out to be?
Yes, sir.
It's like yeah, it's a, like multiplication. x1 के साथ x1 के साथ x like 2x1 के साथ x1, 2x1 के साथ 3x2, 2x1 के साथ x3, 3x2 के साथ x1, 3x2 के साथ 3x2 and 3x2 के साथ x3. Okay, so if you like do it, you already know that IID. Okay, so x1 के साथ any other x2 or x3 will be always 0. So therefore, it turns out that the positive and non-negative terms will be this and this one. So it will turn out to be covariance of 2x1 comma x1 plus covariance of 3x2 comma 3x2, right? So other terms will be 0. Do you understand that?
Yes, sir.
So now you can easily check that it's equal to twice of variance of x1 plus twice and I think 9
Of x1, x2.
yeah, 9 variance x1 x2. Okay, so which are positive. Okay, so therefore it's not 0 and therefore they are dependent upon each other, right? So they are not independent, so you cannot tell, but that's a very good idea that we are checking easier conditions that whether these are independent or not. That's very interesting idea because that should be the first step. You should think in that aspect whether these two things are independent or not. That's a super like great idea. So this is something you should check always, like the easier cases that you can easily check. Okay, so it's coming out to be not independent, so somehow there can be like there are two different ways of doing that, therefore, so you have to find the distribution of this entirely, right? Or there may be some interesting other ideas. Okay. So all of you understood the discussion till this point of time, that how it's going. So essentially, you have many other ways of doing that. So you can either find out individual x1 given this and x2 given this distribution, or you can find out the individual together as a distribution, whatever you want to find out. But there always something interesting, some interesting way to go through the solution. Okay, so I will present to you some two different ways of doing that. Number one, I will show you the idea of symmetry of random variables and how to use that to solve this problem. Symmetry of random variables. So I've already shared certain, like I will solve it in two different manners. Okay, this will be a bit longer, but is to make you comfortable in your own skin about the symmetry of random, how to deal with the symmetry, because that's a very important topic per se. So let's understand. So we are asked to find expectation of x1 twice x1 plus thrice x2 given x1 plus thrice x2 minus x3 is equal to 4. So one thing, understand that these things are like independent. Okay, so let's understand this very carefully. So I will exactly do in the terms of understand this very carefully. So I will go in the approach of Madhav. Okay, and let's call this y1, y2, and y3. So if you find it out, therefore it's equivalent to finding twice expectation of x1 given y1 plus y2 plus y3 is equal to 4. So x1 is equal to y1, so I can replace x1 by y1 plus, observe that expectation of thrice x2 given y1 plus y2 plus y3 is equal to 4. So this thrice x2 is equal to y2, so it's equal to this. So do you understand that we can write it as twice expectation of y1 given y1 plus y2 plus y3 is equal to 4 plus expectation of y2 given y1 plus y2 plus y3 is equal to 4. Did you understand this, guys? Did you understand this step? All of you? Yeah. Okay, so now you see a very interesting interesting spot. The pattern in that y1 given y1 plus y2 plus y3 and y2 given y1 plus y2 plus y3. This gives an opportunity, or like door of opportunity, to apply the ideas of symmetry. I mean, there's an inherent symmetry in the expression. So how to exploit that symmetry and like go ahead and understand the ideas of the solution. So one way to do that is, let's understand the behavior of this. So these are random variables, right? So we can write that y1, so these are the random variables. y1 given y1 plus y2 plus y3 is equal to 4. This is one random variable. The other random variable is y2 given y1 plus y2 plus y3 is equal to 4. This is another random variable. Okay, and there is y3 also. So there is no y3 over here. Y3 given y1 plus y2 plus y3 is equal to 4. Okay, so understand this very carefully. So if we do expectation of all of this, let's call it alpha 1, Let's call the expectation of this as alpha 2. And let's call this expectation of this as alpha 3. Okay. So we are required to find out what? Twice alpha 1 plus alpha 2. Okay. Now, therefore, it's like sort of forcing you somewhere to find out alpha 1 plus alpha 2 plus alpha 3, right? Like this, you're asking to find out alpha 1 plus alpha 2 rather. So let's try to, so using the symmetry idea, we will sort of go into this. So let's find out alpha 1 plus alpha 2 plus alpha 3. Can you find out alpha 1 plus alpha 2 plus alpha 3, guys? Any ideas how to find out the alpha 1 plus alpha 2 plus alpha 3?
Sir, will it be 1?
Why is that so? So
Oh
first,
no.
yeah, bola.
I was applying the concept like the alpha 1 plus alpha 2 plus alpha 3. We can write it like expectation of y1 plus y2 plus y3.
You're right. Let's do it.
Given y1 plus y2 plus y3 is equals to 4.
So
it will be 4.
very good. So it's given that y1 plus y2 plus y3 is constant. And it's asking you to find out the expectation of that given that constant. So it is 4, right? So alpha 1 plus alpha 2 plus alpha 3 is coming out to be 4. All of you understood this? All of you understood this idea? Alpha 1 plus alpha 2 plus alpha 3 is coming out to be 4. By the way, who are the new students out here? Vasant, I think, is a new student, right?
Yes, sir.
Hi, Vasant. So after the class, Vasant, I will talk to you about your own preparation on how to how to do and approach the examination. It's coming forward. Okay, so I will repeat that again. So we are adding alpha 1 plus alpha 2 plus alpha 3. Why we're adding that? Because the expression in some sense on the left hand side is sort of forcing you to find out alpha 1 plus alpha 2 plus alpha 3. Okay, rather it's asking you to find out twice alpha 1 plus alpha 2. So it's better to find out alpha 1 plus alpha 2 plus alpha 3 because it gives an inherent symmetry. Why is symmetry coming up? The symmetry is coming up in this, that expectation, you will now, like, symmetry has not come up literally as of now. The symmetry is in the expectation. So if you do alpha 1 plus alpha 2 plus alpha 3, you get that if you use the additive property, you get expectation of y1 plus y2 plus y3 given y1 plus y2 plus y3 is equal to 4. So what does it mean? This means that given y1 plus y2 plus y3 is equal to 4, that it's already given that it's a constant. It's asking you the expected value of that random variable. It will be 4, right? Because it's a constant. So it's asking expectation of 4 given this. So that's 4, right? Did you understand, guys? Did you understand? Vasant, are you understanding?
Yes, sir.
Dev, did you understand?
Yes, sir.
Okay. Any doubts, guys? All of you understood that? This idea, this subtle idea? Okay. So we have got that alpha 1 plus alpha 2 plus alpha 3 is equal to 4. But we are required to find twice alpha 1 plus. So we are required to find twice alpha 1 plus alpha 2, and we know that alpha 1 plus alpha 2 plus alpha 3 is equal to 4. So let's subtract this. So let's try to write it in terms of alpha 1 and alpha 3. We can write it as alpha 1 minus alpha 3 plus 4. Can we write like this? I just replaced alpha 2 in terms of this. So we can write like this, right? Alpha 1 minus alpha 3 plus 4, right? Guys, can you understand this? It's very easy. So now, so therefore, it's asking you that to find a relationship between alpha 1 and alpha 3. So now this question is asking you, now this turns out to be that point where it's asking you to find the relationship between alpha 1 and alpha 3. What is alpha 1 and alpha 3? It's asking that find expectation of y1 given y1 plus y2 plus y3 is equal to 4, an expectation of y3 given y1 plus y2 plus y3 is equal to 4. So let's see what is y1 and y3. So y1 is nothing but x1 and y3 is nothing but minus x3. So let's understand this now. Here is where the symmetry principle will come in. So expectation of, so understand, x1 given y1 plus y2 plus y3 is equal to 4 and minus x3 given y1 plus y2 plus y3 is equal to 4. Now understand this. x1 is distributed similarly like x3, right? Both are standard normal. And x3 is distributed similarly like minus x3. x3 and minus x3 are similar because it's standard normal. They are symmetric around 0. So therefore, x1 and x3, like both minus x3 and x1 are standard normal random variable, and they are similarly distributed. So conditioning on the fact on the same subspace, conditioning on the same space, and given that x1 and x3 are independent, and IID in fact they are. Since x1 and x3 are IID and conditioned in the same space, these two are similarly distributed. Can you understand this? x1 given x1 y1 plus y2 plus y3 and minus x3 given y1 plus y2 plus y3. So it's asking this. Since y1 and y2 are same distributed, so this is asking this. So y1 given y1 plus y2 plus y3 and y2 given y1 plus y2 plus y3 are similarly distributed since y1 is similarly distributed as y2. It's not same as y2 given this, sorry, y3. It's not same as y2 given this because y2 and yi is y1 and y3 are differently distributed. So this will not be the same. Do you understand this, guys? This is where the symmetry is coming up. Did you understand, guys? Any doubts? Others, did you understand or do you want me to repeat? Yeah. Tell me, guys. So Param is asking. Okay. Yeah, sure. Understand this very carefully. y1, y2, and y3. Okay. Is equal to 4. This is an event. This is set. Okay, in the sample space. So conditioning on that event, that is has already happened. We are trying to find out the distribution of y1 and y3. Now it turns out that y1 and y3 are similarly distributed. Okay. So y1 given the same event space and y3 given the same event space, given the given the data that they are IID. Okay, given data that they are IID. Y1 and y3 are IID. Why? Because y1 is x1 and y3 is minus x3. And x1 and x3 are both standard normal random variable, and since x1 x3 is standard normal random variable, and due to this symmetry of the standard normal random variable around 0, minus x is also standard normal random variable, and x1 and x3 are standard normal random variable. So x1 and minus x3 are also standard normal random variable, and they are IID because x1 and x3 are IID. So y1 and y2 are IID. They are same distributed. Okay, so y1, that's the idea. So you can actually prove it mathematically over here by using PDF. That f of y1 is equal to y given. Let's do it. So how do you prove it mathematically? So let's do it. F of how to prove that they're equally distributed, or whether I may be wrong. So let's check that. So you use the idea that use the idea of conditional distribution. by of 4, right? And similarly, let's do the other one, y3 ka. So you will get ऊपर में you will get नीचे will be same. The ऊपर में you will just get that ऊपर में you will get the thing that f of y3 is equal to y, and y1 plus y2 plus y3 is equal to 4. So what turns out? It turns out that here it turns out f of y1 is equal to y and y2 plus y3 is equal to 4 minus y. And here it turns out that f of y3 is equal to y and y1 plus yt is equal to 4 minus y. So what happens? y1 and y2 are similarly distributed, and y2 plus y3 and y1 plus y3 are similarly distributed, and they're independent together. So both are similarly, both the expression are same. Did you understand that why both the expressions are same? Did you understand why both the expressions are same, guys? All of you. This is a mathematical way of expressing that, but since as you are growing your experience, you will understand that both of them will be having the same distribution when they're IID, and that's the basic idea. So both are having the same distribution, and therefore they are similarly distributed, and therefore the expectation are also same. So y alpha 1 is equal to alpha 3. So this is getting cancelled. So this is 4. So therefore the expectation is coming out to be 4. All of you understood the solution, guys? This is a very intricate solution. This is not how the solution is done exactly. There's a much easier way of solving this problem. But I took this different approach because I want to show you how one problem can be done in various different ways, which enhances your perception about problem solving. All of you understood this, guys? Any doubts?
Okay, means in that expression 2 alpha 1 plus alpha 2, then alpha 1 and alpha 2 are identically distributed, means symmetrical.
Alpha 1 and alpha 2 are numbers, so they're equal.
Yeah, equal. Yeah, but y1 and y2 will be similarly no, y1 x2 and x1, or x1 x2.
X1 x3 you mean? Yeah, I'm not understanding what you're telling me.
Yeah, you prove from x1 and x3 they both are similarly distributed, so that alpha 1 alpha 3 equal.
Yeah, y1 and y3 are similarly distributed. X1 and minus x3 are similarly distributed. Y3 is minus x3. Why? Because if x3 is standard normal, minus x3 is also standard normal, right? Why? Because it's symmetric around 0.
Yeah, I've got that. I was saying that alpha 1 and alpha 2 will be equal, but no, it will be not.
Alpha 1 and alpha 3 will be equal.
Yeah.
Alpha 1 and alpha 2 are not equal.
Yeah, okay.
I mean, you can easily understand that. They are not similarly distributed, number one. So if you put y2 is equal to y, this will not come out. The main idea is that y1 and y3 are similarly distributed, and this, like, since y1 and y2 are similarly distributed, y1 plus y2 and y2 plus y3 are also similarly distributed. Okay, so therefore this will break up into splits. Will split up due to the independence property, and you will find out easily. Okay, I mean, there is a very important ideas about this, like how I am being able to tell you so properly that these are symmetric without doing the calculation, because there is something you will learn in your machine learning if you learn theoretical machine learning in future, and I'm doing some work on that now. It's called graphical models. Okay, so graphical model is actually done by, I don't know if any working professional over here. So they have done something called Kalman filter. Okay, Kalman filter. Sorry. Kalman filter, which is a very important idea in machine learning, and these things are really developed on the ideas of this graphical models. Okay, so graphical models is nothing but a graphical way of representing the entire conditional probability and stuff like that. So when you visualize that graphically, automatically, okay, these two are independent and these two are similarly distributed. You can automatically tell that. So using that, I am being able to tell you so fast, but you will also still it's like see the you'll understand it more and more details, man, as you will do more and more problems. So that's the idea. But I always ask you, like, whenever there is independence and IID nature, things are really going good and you can really do easy stuff. Okay, and it's actually an intuition match. More like 90% of the time intuition will match. So that's why it's very useful. So that's from that perspective and experience I told that they will be identically distributed, and I think personally that this computation is more important. So I hope all of you understood that they're identically distributed, right, guys? Like, and all of you understood this way of solution. Sneha, did you understand? It's like, read the message. My screen is broken at that point. Sneha, what did you write? And I cannot see actually.
I was asking the second method.
Second? Oh, oh,
You said,
second
is
method.
it?
Yeah, sure. It's very easy. Second method is really easy. Solution in the second method, but I want to share this. So, if I would have told you the one-step method, you wouldn't have you would have felt that the first method is not useful. So, I told the longer one. So it's very easy. So we are using this result: expectation of two random variables v, given the fact that v is equal to u, is expectation of u. This is something really important. So it's known that asking the expectation of v given v is equal to u. It's same as telling, like, we know that v is equal to u. So therefore expectation of v given the information that v is equal to u is what? Expectation of u. Just normal logical way. So if we use this idea, so let's use this idea over here, and so let's call it v. So expectation of v given, we need to find it in terms of v is equal to u format. So let's find it out. What is that u? So v is equal to, that means twice x2. So you have to add twice x2 over here, and this x3 will go and plus x1 will go. So it's equal to 4 plus x1 plus x3. This is the u part. So expression of v given v is equal to 4 x1 plus x3 is what? Expectation of 4 x1 plus x3. And x1 plus x3 are IID normals, so standard normal. So and their expectation is 0. So this is coming out to be 4. So this is super short method of doing that. Okay, and it's super interesting and super easy. Actually, it just goes logically. But the next previous method is actually very wide ranged use. So these are two different methods of solving the same problem, and both are important in some way or the other. Did you understand the solution, guys? The second one. Yeah, sure. The idea is that expectation of v given v is equal to u is expression of u. This is the basic idea. Okay, let's prove it. Let's prove it. So expectation of v given v is equal to u is equal to y is equal to expectation of u. Let's understand this. So we need to find v given v is equal to u. So f of, let's do it for continuous random variable only. F of v given v is equal to u of v. That means what? Let's do it very basically, from very basics, okay? So we are using conditional distribution. So expectation of v is equal to v and v is equal to u by f of v is equal to u. Okay? And this is what? So this is equal to f of v is equal to v and u is equal to v by f of v is equal to u, right? Very simple, right? And u and v may be related to each other. So this is the basic idea. Now, this is the basic idea. So let's do the integration. So integration v, f of v given v is equal to u of v dv, this will turn out to be what? Integration v, f of v is equal to v and u is equal to v by f of v is equal to u, right? dv. Okay, guys. So let's understand this. We are trying to find out using continuous distribution only that f of v given v is equal to u. This is same as f of v given v is equal to u. It's same as you just using the conditional. So okay, there is certain problem over here. There's certain problem over here which I did, and the problem is the following: is that this event is a very big event. So something like, yes, so this is like f of v minus equal to 0 in that sense. Okay, so it's v minus u is equal to 0. Yeah, in that sense. So this is a very important idea. It's v minus u is equal to 0. So f of v is equal to u means that. So there's some like probabilistic issues are over here. So I'm just addressing that because it requires major theoretical understanding. But the idea is that this is same as, you can write it as, I'll just clear the frame and write it in a different way. A random variable. So expectation of v given v minus u is equal to 0. This can, because it's a random variable, so it means an event. Okay, so then you can write f of 0 in that sense. So that's why I'm just writing in that sense. So this is expectation of you need to show, and this is what, this is indicator, sorry, integrate, sorry, let's find out the this f of v given v minus u is equal to 0 of small v. So now using the conditional distribution, it's f of v, sorry, f of v comma v minus u of v comma 0 by f of v comma f of v minus u of 0. And this statement that f of v comma v minus u of 0, and like these are looking same actually. This is same as f of v comma u v comma v. I mean v comma v is equal to v and v minus u is equal to 0. This event, like this, a neighborhood around this event is same as v is equal to v and u is equal to v. So therefore we can write it like this: f of v comma u is equal to v comma v of v comma v by f of v minus u is equal to 0. So this is something which is interesting. Now the question is that if you do expectation of this, how does it come out integration? Like how does it come out expectation of u? That's the interesting question. So any ideas? How does it come out? Any ideas? So Sneha, can you just unmute yourself and tell the doubt? I cannot see because of my screen broken.
No, so it's fine now.
Okay. Okay. So all of you understood till this point of time, guys? How the calculation is being done? So I'm stretching it out because I am making, yeah.
How there is v comma v in numerator.
Yeah, actually my handwriting, I didn't get you. Can you come again?
So I didn't get how did you wrote v comma v in the numerator.
Yeah, I'm getting to that.
So can you use different notations? Actually, u and v are like they're seeming.
Yeah. Sure. Thank you for telling me that. So let's call it x and y. So expression of x, sorry. So x given x minus y is equal to 0 of small x. It's turning out to be f of x comma x minus y of x comma 0 by f of x minus y of 0. Okay? And we can write it as f of x. So x is equal to x and x minus y is equal to 0. This event is same as x is equal to x and y is equal to y, right? Sorry, y is equal to x. We can write it as x comma y. So we are changing from x comma x minus y to x comma y of x comma x by x minus y of 0. Did you understand this till this point of time?
Yes, sir.
So now we need to show that, yes, good. Now we need to show that integration of this x of this f of x comma y of xx by f of x minus y of 0 dx is actually equal to integration of some t or y f of y dy. So how do you show this? That's my question. So my question is, how do you show this? Yes. So how do you show this? This is very interesting, and yes. So so is there an easier way out? Is there an easier way out? Tell me. Bolo. Any ideas, guys? How's the same? Any ideas? How do you do this? Tell me the ideas you're having in your mind. Do you know law of total expectation, guys? Do you know law of total expectation? So what is law of total expectation? It's telling you that expectation of x, this can be written as expectation of x given a1 if a1 a2 are is a like if the whole sample space can be divided into a1 into an disjoint partitioned. So it's expectation of a1 into probability of a1. I think this will be taught to you or maybe have been taught. Plus dot dot dot. This is law of total expectation. So can you just apply this over here in some sense? Can I apply this over here in some sense? How will you do this problem? Tell me. What's going on in your mind? Yep, so tell me. So expectation, so you feel that, I will just give you a hint. So do you feel that, if it was given like this, expectation of x given, x minus y, x is equal to y, right? It was given if x is equal to y is equal to some number, let's say, alpha. So then this will be what, guys? This will be what? This will be alpha, right? This is alpha, right? All of you understood this is alpha. It's given that x is equal to y is equal to alpha. This is alpha. So what if it was given like this? So this is also same as expectation of yeah. So this is alpha, right? So can you use this idea to sort of show that it's equal to expectation of y? Are you getting the idea? In some sense, when you're fixing this x is equal to y, we are telling that actually x is behaving like only y. Like x is actually equivalent to y. How can you mathematically show that? There's certain things that you should think about, like not only just solve the problems by the solution. That's why I just sort of thought of, I didn't have planned to do this, but I thought of sort of stopping by and showing you the idea. So expression of x given x is equal to y is equal to alpha, why this it's equal to alpha. So this sort of gives an intuition that it will be actually behaving like y in some sense, like, or can you show like this? X given x is equal to y is actually y. Can you show like this? That actually, if the expectation is not the thing, but the y is actually the thing.
So we can do it like x is equal to a random variable y. So we can exchange y and x. It's okay to write y in place of x then.
No, you have to do it mathematically. You understand? You have to do it mathematically. So now, here, can we write it same as f of y of x? Can we write like this or not? So my question is that x given x is equal to y, is it same as y? That's my question. X is equal to x given y, x is equal to y is this random variable. So my question is that this is it equal to y? Let's forget the expectation. So equal to y means what? The PDF must be same, right? Iska PDF is same as uska PDF. The question is that whether they're equal or not. Yeah, tell me. Let's see x and y over here. Can someone tell me the expression over here? X and y are what? It's expectation of twice x1 plus thrice x2. This is the x is equal to x1 twice x1 plus thrice x2 minus, or rather equal to, let's say minus, this is x1 x minus x1 plus x3 minus 4 is equal to 0. Yes. So when can you write this? Tell me, guys. When can you write this? It's very easy. Tell me, when can you write this? That means it's equivalent saying that y of x comma x is same as f of x minus y of 0 into f of y of x. When can we write like this? Or if you just consider the first one, it's telling that x comma x minus y of x comma 0, it's same as telling f of x minus y of 0 into f of y comma x. You can understand if x minus y and y are independent. X minus y and y are independent. Then we can write like this: x comma y of 0 comma x, and we can easily understand this event x minus y is equal to 0 and y is equal to x is same as this, right? So we can only write this if x minus y is independent of y. Did you understand this? So is this always true or is this always not true? Did you understand this? That we can only write this if x and y, x minus y and y are independent. Otherwise, that will not be spreading out, right? Did you understand this, guys, or do you want me to repeat it again? Yeah, I'm sorry, I got out of the meeting somehow. I will just Yeah, I sort of got out of the meeting. Just give me a minute. Yes. So tell me now, how are you planning to understand this for the next step? So did you understand that we can write this if and only if, not if and only if x minus y and y are independent, right? Did you understand this, guys? What do you think, guys? Tell me about your ideas. What do you think? Others, did you understand this? Vasant, are you understanding? That this will only hold true if x minus y is independent of y, right? Otherwise, will it hold true? Okay, sure. Did you understand this calculation, whole calculation over here?
So in last part, how did we write f5 of x?
बोलो बोलो फिर से बोलो.
So how did we write f5 of x?
No, that we are trying to show, right? That is what we are trying to show. Like we are trying to show that x given x minus y is equal to 0 should be behaving like y. Is that we are trying to show? Is it true only when expectation of y and x minus y are independent, right? So this is what we are trying to show.
Sir, but x and x minus y cannot be independent.
X nahi, y and x minus y.
Yeah, but x minus y and y also cannot be independent because y is included in the former.
Okay. Yes, you're right. So let's calculate expectation covariance of x and y, x minus y and y. It will be what? Covariance of x and y. And we know covariance of x and y is not 0, right? This is x and this is y, and covariance of x and y is not 0. No, I'm so sorry. We are understanding covariance of xy, x comma x, y comma x minus y, right? And this is x and this is x minus y. So let's understand this. It's covariance of xy minus variance of y. So covariance of xy is what? 2 times variance of x, 1, right? Nothing else is there. X1's only x1 is there. minus variance of y is what? Minus variance of y is variance of x1 plus x3, right? And therefore, understand this. This is exactly the idea we used. This is what? It's twice variance of x1 minus variance of x1 plus x3, which are equal. So this is 0, right? If you understood the beauty of this, the two things are equal. It's only happening since x1 and x3 are IID. It will not happen otherwise. Did you understand this, guys? Or will I repeat again? All of you understood this, or will I repeat again, guys? The whole solution once. The second time. Actually, the second time is actually, I thought that it was much more easy, but it didn't turn out to be easy. Actually, the same criteria we're using over and over again. It's a very intricate problem. I like it actually. I directly used that result before, but I now sort of proved it myself that actually it is not true always. All of you understood this, or I will repeat once again, guys? Tell me. If you want me to repeat, I will repeat it. Everything clear? So it's understand why we are using the covariance over here, because covariance of two non-random variables is 0 if and only if they're independent. So we have shown that y and x minus y are independent by showing that y and x minus y are their covariance is 0. Right, guys? All of you understood this? You enjoy this problem? So it's a very intricate problem, and we proved it that x and x, y and x minus y. I mean, it wouldn't have been the case if it was instead of x3, it was twice x3. So the homework problem for you is to find out. So this is the beauty. This is symmetry we are using all over again. Okay. So here the only thing that is useful is that x minus y and y are independent of each other. Okay. And that's coming out to be exactly the same. This wouldn't have happened if it was not normal. Okay. So this is not a general thing. So it's only true if x minus y and y are independent of each other. Otherwise not. Okay, guys, all of you, can I move on to the next problem? So this is just the first problem done. It's a very intricate problem, actually. It almost took 1 hour, but I discussed two different ideas. All of you like this problem? Like the two approaches? Anyone who thinks it's a waste of time to do this one problem in two different ways? Okay, good. So this is where you should explore yourself. This is where you should understand what is done and what is not done, what could be done and what could not be done. That's why you're like it's enjoyable. Okay, all of you, any doubts, guys? Any doubts in this? Because very intricate idea, so you need to have some doubts. I believe you must be having some doubts. Vasant, Tishika, Shuprobo, Sneha, Shayanar, Satej, Shoikot, Mansi, Nikhil, Paulami, Pratiksha, Proma, Madhav Dev. Did you understand it? Good. Perfect. Okay, so let's move on to the next problem. I think I couldn't discuss this problem. I will not be able to discuss the doubts of today, but let's discuss this problem. This is a super interesting problem. Okay, so coming back to the last day's problem, like 22nd September's problem. Is this is something really interesting, and any ideas, guys? Any ideas of how to do this? How will you use the idea? This any ideas? This is based on a very simple and interesting property. Do you know the property, guys? It's a very beautiful relationship between Poisson random variable and binomial random variable, and this is like except the limiting sense aspect.
So can we use the same approach of conditional and expectation?
Okay, so tell me what approach you have in your mind.
Like you told expectation of u, v given u, v is equal to u is expectation of u.
क्या?
Expectation of v given v is equal to u is equal to expectation of u.
See, Tishika, I told you, that's why I gave a warning. This is only true if and only if x minus y is independent of y. Otherwise not. That's what I've proved here. Okay. So here, if you're trying to do that, expectation of x1 given x1 is equal to 6 minus x2, it will only happen if x1 or other, here is the y, here is the x. It will only happen if 6 minus x2 is independent of x1 plus x2 minus 6. Right, Tishika? So this will only happen if v minus u is independent of v. Did you understand? Okay, Satej, I cannot see your message. Can you please tell me the message? So this is super important, guys. Yeah, I will come to that. Will it directly follow binomial 6, 1/3? Yeah, I will. Yeah, it follows. I can see your message now. I will show that. But Tishika didn't understand the core difficulty in using this result. This is not always true, okay? So don't make this mistake during the exam hall.
Yes.
You can understand that also you will not find covariance from here because it's a Poisson. So the idea covariance will not hold over here. Okay? So we need some different mechanism and technology to do it. So Polam, I didn't get you an idea. And then we can take expectation, no problem. What is that?
Because after it follows binomial, then.
Oh, okay, yeah. So this is a very famous result, okay? Poisson given Poisson is. So when I learned this, like I sort of learned the usefulness of this result when I was learning the categorical data analysis course in ISI MStat first year. So there, this result was very useful because conditionality was the heart of categorical data analysis. So what's done over there is the following. Okay, let's not go with that. So here the basic idea: x1 given x1 plus x2 is equal to n. So x1 and x2 are Poisson. Follows, so Poisson, let's say x1 follows Poisson lambda 1 and x2 follows Poisson lambda 2. So x1 given x1 plus x2 is equal to n follows binomial n, capital N, this capital N, comma lambda 1 by lambda 1 plus lambda 2. So the homework after this class is that you should write down the proof of it and share just after this class, okay, in the WhatsApp group we have. But I will give you the intuition now that why this is true. Okay, so you prove it use conditional PMF, joint PMF to prove this. It's very easy, not very hard. Oh, by the way, x1 and x2 are independent. Sorry, x1 and x2 are independent, so that is important.
Sir, can you repeat? So what should we prove, sir?
You prove that if x1 given so x1 and x2 are Poisson lambda 1 and lambda 2 independent, prove that x1 given x1 plus x2 is equal to capital N follows binomial n comma lambda 1 by lambda 1 plus lambda 2.
Okay, sir.
Like use a basic conditional PMF idea and you can send the solution to me personally. I will check that. Okay, so that's very important. So writing mathematics is super important. So we will use this idea, but now what I will show you is an intuitive explanation of this. Okay, the proof is very easy. Okay, I'm not going into the details because you are being capable of doing that. You have the technological ideas, the mathematics behind it. You know the definition of it, so you can do that because Poisson lambda 1 like x sum of 2 Poisson is again Poisson. Okay, sum of 2 Poisson is again Poisson, independent. So you can use that property, Poisson lambda 1 plus lambda 2. So this follows Poisson lambda 1 plus lambda 2. This is a hint. You can use this property and find out the distribution of x1 comma x2 and that. But use the idea. So convert it from x1 comma x1 plus x2, that joint random variable, to x1 comma x2. That is the basic idea. Because you know that they're independent and you can break it up. That's the basic idea. Okay, so let's understand the intuition behind it. Anyone who wants to try this intuition out? x1 and x2 to Poisson. How to try out this intuition? Any ideas, guys? Any ideas? How to try out this intuitive explanation of this?
Sir, for Poisson, we can use the limiting case from binomial to Poisson. So when p tends to 0 and n is very large.
Okay, go ahead.
It's a Poisson distribution. So the ratio of 2 Poisson distribution means the first one has very less probability and very large number of trials, and the second one also has the same thing. So we are taking up the ratio now. So the probability is like dividing a very small quantity with a very small quantity.
Okay, that's a very good idea. So Sneha is telling that since binomial ka limiting form is Poisson, this is coming out to be much more probable to be a Poisson. So let's understand that, okay, why this can be true. So there's also a relationship between hypergeometric and binomial. Okay, but let's not go into that. The conditional relationship. But let's not go into that. So understand this is very important. So let's give an example of a Poisson distribution. I did this in my previous classes. Poisson distribution example. The why I'm asking for example, because it will help you to visualize the theory, like an example of that. So given a real life distribution of Poisson distribution, real life example. I discussed that in class. I discussed that in class. Do you remember? So Poisson is polynomial n comma p goes to Poisson lambda if np goes to lambda, as n goes to infinity and p goes to 0. So p is becoming very small and n is becoming very large. So I did a very interesting. So now I want you to tell me this, okay? I mean, this is of probability 2. Good, defective product. No, I mean, there was not there. That's really good. Others, I gave you one really interesting example. Like, you should not forget this. Any other examples you remember, guys? Those who were there, like Tishika was there, Polami was there, Sneha was there. These are customer, okay. But I gave another more interesting example. Rare events, yeah, right? Okay. Yes, so rare events. So rare events, exactly. We model it to, like, we do it to model rare events. And one rare event is reading books. So, printing errors. So printing error is like this, that you have a book. And each page has some error. But it's a very less probability of error. 0.01 typing error. Okay, 0.001 typing error. Word. Each individual word has a probability of this, of being have a typing error. This each individual word. Word follows Bernoulli. P. P is the probability of error. 0.001. Very, very small. And if you sum up all the words, therefore, it turns out what in a whole book. So expected tell me, like, in one page there may be, in one line there are 10 pages, and then words, say in one on average book there are, let's say in one page there are like 15 lines, so 150 words, and there are, let's say, 200 pages. So it is turning out to be what? 30,000. So total number of words error is nothing but number of errors in the book is following what? Binomial 30,000. I think it's really less than that, or maybe like 0.01, I don't know, of 0.01. And this is very small, and you can understand this will turn out to be 1 by 1000. So it's turning out to be 30, around 30 typing errors, which is very reasonable, I guess. 13 typing errors in a book. So 30 total word typos in a book. That's very natural. Okay, that's very reasonable amount of number, like amount of words error. So this is a very real life example how binomial is like. Now this converse actually follows Poisson. This is modeled by Poisson 30. Okay, this is modeled by Poisson 30. That's it. So now let's take this as an example and understand the whole procedure. What is this telling? So we understand that number of typos in a book 1 follows Poisson lambda 1. Number of typos in book 2 follows Poisson lambda 2. So it's telling you that, see, if in the two books मिला के, you know that given number of typos in book 1 plus book 2 is equal to say 10. Asking that what is the probability that number of typos in book 1 is equal to x. Given that the typos in books 1 is equal to 10, 1 plus book 2, so there are two containers, book 1 plus book 2, number of typos over here. It's telling you that given that number of two components, like let's take the first typo, okay? Let's take the first typo that has happened. What is the probability it belongs to the first book or the second book? That's the idea. What is the probability it belongs to the first book or the second book? What is the probability it belongs to the first book or second book? And that's where the idea comes up that on average there are lambda 1 like on average there are lambda 1 errors over there. So probability of an error being that is this, and probability of an error coming from here is this. This is 2 and 1. So therefore the probability that it's coming from book 1 is lambda 1 plus lambda 2. So it's individual each error, given the typo is number of 10, each error follows Bernoulli lambda 1 by lambda 1 plus lambda 2. Okay, all of you understood this? All of you understood this? Anyone who didn't understand? Now there's a very fundamental question that is left to answer. Is that why only for Poisson? Why it will not happen for any other distribution? I mean, let's say you have another distribution, positive, let's say, or let's say you have geometric, P1 and P2. Let's say any discrete random variable, x1 and x2. What makes it so important? The Poisson. What is really making it so important? So my question is that your question is the following. Your question must be the following. You should ask questions that if you are saying that on average Poisson का first one से ऐसा आने का probability है and second से ये आने का probability है, why is not applicable for any random variable? Let's say you have two random variables, x1 and x2. इसका mean है mu1 and इसका mean है mu2. These are discrete. The question is that x1 given x1 plus x2 is equal to, let's say, n. Why is it not following binomial, or will it follow binomial? So let's check that will it follow binomial or not. So probability x1 is equal to x given x1 plus x2 is equal to n. This is like probability x1 is equal to x, and they are independent, of course. And x2 is equal to x1 plus x2 is equal to n by probability x1 plus x2 is equal to n. So probability x1 is equal to x. So this is same as probability x1 is equal to x and x2 is equal to n minus x by probability x1 plus x2 is equal to n. The question is that when this will follow binomial n comma mu1 by mu1 plus mu2, when this will follow, because we are giving the logic that इसमें on average probability आने का like mu1 plus mu2 है, and here on average probability आने का mu2 plus mu2 by mu1 plus mu2 है, average. If I take one typo, what is the probability will come from the first one? This is the average. So Why is this not following binomial in all the random variables? Why in only Poisson? That's the question to you. What do you think? Any other ideas? What do you think, guys? Tell me. So what was the logic? The logic was, the intuition was, your first book may on average, like if I take one typo, on average it's like turning out to be here lambda 1 and here lambda 2. So the proportion is lambda 1 is to lambda 2. That is lambda 1 by lambda 1 plus lambda 2 and lambda 2 by lambda 1 plus lambda 2. So if I take 1, the probability of them coming is this. On average. So why is it not holding true for each and every random variable out there? Any ideas? So Dev, I can see your message. Can you just repeat it? Or just copy and paste it once so that I can see it. You can just type any dot because the parameter is average. Yes, but I am just asking you why this is not true for any random variable. I'm not taking Poisson over here. Why we are not taking it for any random variable? That is my question to you. Let's say, so we are telling you that we're trying to understand this probability x1 is equal to x and x1 plus x2 is equal to n by probability x1 plus x2 is equal to n. What this will be? Not in general case. So since IID it's independent, so it's this, and so you can understand that it's p of x and into p of n minus x by probability, like it's summation of p of x and p of n minus x, x from 0 to n. So my question is that this expression, when is this always n choose x, that is Bernoulli, p to the power x, so no, mu1 by mu1 plus mu2 whole to the power x and mu2 by mu1 plus mu2 whole to the power n minus x. Is this only is always holding? Because the logic we are using, we're not using any property of Poisson per se. So why is this true for Poisson? What is the property of Poisson we are using? So this is something I will leave you to think about. Do you understand the question, guys? So Nikhil has some ideas. Nikhil, bolo. Magnitude of probability is small in case of Poisson. Okay. Magnitude of probability is small in case of Poisson. I mean, that doesn't, that, I mean, but how does that help? Like, how does that help here? How does that help here? I mean, I don't understand. Magnitude of probability is small in Poisson, and this is very, I mean, I didn't understand this. So think about it, guys. When this is true. Okay? Think about it. Any other ideas, guys? Anything you want me to share? Did you understand this? we use Poisson for modeling rare events, so not much use here. In this case, need other logic. Yes. So we need some other property of Poisson which is important, guys. Or is it true for only, or is it true in general? Is it true in general or not? Is it true in general? So if you can give me time now, I can show some simulation. I have not done some simulation before, but if you want to continue, I can show some simulations of like, no, I think that will be a bit hard. No, let's not do this today. I will try to make a video on it because I have to do the conditional simulation. But we can take any random variable, any discrete random variable, and we can do a simulation, try to do a simulation. But we can do it for small case. Okay. So how do you know this is correct or not? We can do this for small cases. Let's say x1 take values x1 and x2 are IID, they take values here 0, 1, 2, 0.3, 0.3. Okay, let's take uniformly. x1 x2 take values here, so x1 plus x2 take values. Let's check this out. It takes values 0, 1, 2, 3, and 4, right? And let's check this out. So 0 is 0.3, 0.09, because 0.3 into 0.3. 1 is 0.0, like this plus this, so it's 0.18. 2 is what? 1 plus 1, and 0 plus 2, and 2 plus 0. So 0.3, 0.3, so it's 0.27. 3, 0.09 is there. 3 is 1 plus 2 and 2 plus 1. So 0.18, and here it's 0.09, I guess. Everything correct, I guess. 0.09, 0.18, 0.18, 4 times. Sorry, 3 times. I think there is some mistake I did. Did I do any mistake, guys? So we are trying to make a general case, an example, basic example. So this is the idea of problem solving, guys. So I don't know the solution of this. Clearly, I don't know, okay? What is the truth? It just suddenly came to my mind now. So I'm just trying to explore. And I have taught you this, how to explore a problem. You may not know. What you do is by exploring, taking small general cases and understanding it to the very basics. So I'm just worried that this sum is 0.54, 0. Sum is not coming out to be that thing. So something is wrong. 2 is 1 plus 1. 0 plus 0.3, 0.27. Something is wrong. 0.11. 0 is 0.1. 4 is 0.09. I missed something maybe. Am I missing something, guys? Is the sum 1? 0.54. No, its sum is not 1. Sum is 0.81. Did I miss anything, guys? Are you understanding what I'm trying to do? Please say yes or no. I will explain it again. Yeah? Please answer. Others? Are you understanding or just like sitting? Are you not understanding? None of you are understanding what I'm trying to do? Why I am writing this? If it's no, please tell me. Otherwise, I will tell you, no? If you don't communicate with me well, how can I understand? No, do you understand why I am doing this? The question why is much more important. So you should be telling me, no? So did you understand the question over here I posed previously? So what I'm trying to do is that I'm trying to see whether this is true for all the cases, all random variables, and I don't know the solution. So what I'm trying to do is that I'm trying to get a very general, easy random variable, x1, x2 with this PMF, it's uniform, and I'm trying to find out the probabilities, the conditional probabilities, to check whether this is always binomial or not. Do you understand now? Because we have a hypothesis in mind, we have a problem in mind. Do you understand now or not? Only two people understood? Yeah, please communicate in the class, okay? It's very important. Without the communication thread, it's very hard for a teacher to understand whether his ideas are like permeable or not. Okay. So we are trying to understand the. So my question is that I have done something wrong over here in calculating the x1 plus x2 probability. So what is that problem? What is the problem I did? Can someone point it out? So x1 and x2, did you understand the distribution of x1 and x2? I'm doing a PMF. So my question is that if this is the case, then what is the distribution of x1 plus x2? PMF, joint PMF. From joint PMF of x1 and x2, it's of course independent. So PMF of x1 plus x2 now, the singular PMF. So zero कैसे आ सकता है? So I expect you to understand this unjoined distribution. Did you understand why I wrote like this? Why these probabilities are coming? Do you want me to explain it again in details? Are you understanding how these probabilities are coming?
So, but the probabilities aren't summing up to 1.
Exactly. So somewhere I have done mistake. That's why I'm asking you to point it out.
So initially, the joint PMF is also not summing up to 1.
Oh, yes. The reason is this. Because this is not 1 itself. Yes, so sum is not 1 itself. That's why it's not coming. Thank you. So it's 1 by 3, 1 by 3, 1 by 3. So 0 is nothing but 1 by 9. This is also 1. This is 2 by 9. This is 3 by 9. And this is 2 by 9. 3, 6, 9. Yes. So this is coming out to be a valid PMF now. So let's calculate x1 given x1 plus x2 is equal to 3. So how do you calculate this? So let's draw a table. This table is super important. So understand this. So we are trying to calculate this. Probability x1 is equal to x and x2 is equal to an given x1 plus x2 is equal to, let's say, 3. Let's consider this 3. So given x1 plus x2 is equal to 3, x1 can be what? 1, x2 can be 2, or x2 can be 1, x2 can be 1, and x1 can be 2, right? Yes, so these are the only two possibilities. So even 0 is not possible. So even 0 is not possible over here. So in binomial, 0 is even possible. So it's not 0 is not even possible over here. So कुछ तो गड़बड़ है. Let's read for geometric then. x1, x2 follows geometric P. Probability. So geometric P ka sum is negative binomial. So what is the distribution of this? Is n. So probability x1 is equal to x and x2 is equal to n minus x by probability x1 plus x2 is equal to n. You find it out. For this, you find it out after the class. It's easy actually. Okay, I will do it. P to the power x into 1 x minus p into 1 minus p x whole to the power x minus 1, and here it's p into 1 minus p whole to the power n minus x minus 1 by x1 plus x2 is equal to n. So it's negative binomial. So negative binomial का क्या होता है? Do you remember the PMF? Negative binomial PMF क्या होता है? You can search it online. No worries. I also forget it. So what it is, there are, let's do it from very scratch. So two successes are there. Two successes are there. And last one तो यहाँ पर ही होगा. So it's you're choosing the rest of the places. So n places are there, capital N. So the rest of the another success के लिए n minus 1 places है. Then n minus 1 into p square into 1 minus p whole n minus 2. So last success is happening over here, and the first success can happen anywhere in the n minus 1 places. So n minus 1, choose one, which is n minus 1. And this, you can understand p square gets cancelled, and it turns out to be 1 by n minus 1. It's uniform. It's turning out to be 1 by n minus 1, which is uniform. Because it's x1 starts from 1. It's uniform. This is interesting. It's uniform. It's not binomial. It's turning out to be uniform. Right? So what is the fundamental issue over here? Think about it, guys, okay? Did I do some mistake, guys? Satej? Okay, so this is uniform, so it's not coming out to be binomial. So you have to understand the fundamental properties why it's coming out to be binomial in the previous case. So think about it. Okay? Think about it. It's very important. All the best, guys. I just dragged too much, and also I didn't discuss the doubts. So I plan to discuss the doubts soon in the next class, maybe. Okay? But regarding these two problems, I think the best way to approach it, let's do okay, I will ask, I will do these doubts soon in the next classes, or maybe solve the problem a day. But these two are very easy. These two can be done easily by the fact that the behavior of n. Okay, so log n is actually, so log n actually behaves much like, you know, So you can actually divide it up like this. Let's take this one. Let's take this series. Let's take this series. Okay, so understand that. Let's understand that how to find, like how to do this type of like series. The way to do this type of series is the following: is that you have to bound it, and I have told you last that a strategy to do this. So you can easily understand it's forcing you to again use the P series maybe. So what to do is that you can easily understand that root n by 2n squared plus this is sort of behaving like what? This is n to the power half and this is n to the power 2. So it's behaving like n to the power minus 3 by 2, which will converge. And let's take this. Log n by twice n squared. Okay. You can also actually prove it, that this behaves like log n is actually not comparable to n squared. Okay. So you can actually also prove it that so log n actually not comparable to n squared. So do you know some famous inequalities on log? So let's understand this. So understand log x to the power 0.5 x to the power 2 So if you prove it this way, so there's a famous understanding how log behaves, and I'm showing the graph to you. Yes, we can use that. How to prove that? So log x is the red one, n square is the n to the power half is the upper one. So n to the power half is actually bigger than log. So it's also, you can sort of show that this is less than or equal to root 2n. So it's also behaving like n to the power minus. Like actually log x is not comparable to n, okay? N to the power any power is not comparable to log. If alpha is positive, it's always greater than that. You can prove it. So prove that also, it's your homework. So you have 3 homeworks today. Number 1 given. Number 2, find it for like the Poisson one. Number 3 is this. Prove that log x is less than or equal to n to the power alpha for all alpha greater than 0. Or is it true or not for all alpha greater than 0 or not? For which alpha it is that. Of course, I can show it to you that it's not true actually for all alpha greater than 0. For alpha less than what? Which one? What is that boundary? What is that critical point? Because I will show you this. That for alpha is equal to 0.005, it's coming that the green is coming under that. So there is something going on. So therefore, log alpha, log n is less than log x is less than or equal to x to the power alpha for all x. Which is that alpha? For alpha greater than something. Hoga. What is that cute, like soft, sweet spot of alpha? Okay. Alpha greater than 2. No, we have done it for x to the power 0.5 also. We have done it for x to the power 0.5. Think about this problem. It's very important. Think about this. Log x is less than x to the power alpha for each alpha. What is that sweet spot we are looking for? So log x is less than x. Choose certain data. Log x less than x, of course. So x to the power 0.5 we have seen. Okay. X to the power 0.1. Is it true? No. X to the power 0.1 में भी नहीं हो रहा है. 2. Is just kissing it for 0.15. No, it's not happening over there. Think about which is really happening, why it's really happening. So think about this problem. It's a super important problem, and this type of problems actually will build your future research and ideas about how to solve problems. This is how you ask questions. If log x is less than alpha for which alpha, and for which algorithm. Okay, all of you, all the best, and I left you with a lot of interesting problems today, a lot of interesting research ideas to think about it, and that's how you should be learning problems and doing problems and answer problem solving capabilities. So I hope you enjoyed it, and please do share the solutions in personally or in the WhatsApp group. All the best, guys, and yep, that's it. And our crash courses are starting from the next month. So if you are interested enough, like if you're in a platinum course, you're totally eligible for it. It's free for you. But if you're not for the platinum course, I think you should check out the link below if you're interested in the IIT JAM mock tests. Crash courses. And our mock tests are starting from October also. So like this is where the preparation time begins, guys. So all the best and a very good night to you. Bye-bye.